This video assignment will investigate into how the teaching of programming is beneficial to children's development and how this is most effective when integrated across the curriculum. The software presented in this video will be aimed at early years and Key Stage 1 children. Programming can be described as the process of designing and writing a set of instructions for a computer in a language it can understand. Papler's definition also emphasizes how language clarity is essential for both the program and the user. Programming is a two-step process. The first step is to analyze the problem and design a solution through logical reasoning, decomposition, abstraction, and generalization. The second part consists of inputting program language, which is called coding. This illustrates the relationship between algorithms and code as being separate. Although it is possible to have one without the other, Berry enforces the idea that both of them work best together hand in hand. The first part of the process is referred to as computational thinking. To understand that computational thinking is essential in providing primary children a high-quality computing education, as the skills which underpin this notion enable children to potentially change the world. Computational thinking can be defined as taking an approach to solving problems, designing systems, and understanding human behavior that draws on concepts fundamental to computing. Berthoud represents the foundations of computational thinking as several concepts and approaches which we as teachers want children to apply to all subjects, and not only computing. It is important to understand that developing programming skills within other subjects other than computing isn't merely about using other subjects as a context for learning to code. It is in fact about learning coding as a way to help pupils learn in other subjects too. The national curriculum expectations of the teaching of programming are as follows. Within Key Stage 1, children are taught to understand what algorithms are, how to create and debug simple programs, and how to use logical reasoning for prediction of programs. Programming is exercised further in Key Stage 2, as children are expected to design, write, and debug programs, to use sequence, selection, and repetition in programs, and experiment with different inputs and outputs. Although not required by the EYFS, children begin to apply computational thinking processes through playing and exploring with a floor turtle such as the Bee-Bot. The Bee-Bot has a low program language demand as the code consists of forwards, backwards, turn left, and turn right. However, children are able to apply concepts such as debugging and tinkering by trial and error of working out the algorithms. This reflects a constructivist approach to learning, as children are able to come to their own answers through their own personal experiences. As programming should be taught with a progressive approach, children are then prepared to use more abstract software in Key Stage 1, which consists of simple coding, such as the Bee-Bot's app, Scratch Junior, or J2 Code. However, this software allows children to visualize the code and identify what part of the code is inaccurate, a benefit not present in the physical floor turtles. Children's learning through a cross-curricular approach has many benefits in contrast to learning subjects within isolation, in particular computing, as it is already recognised within a curriculum that computing has deep links with maths, science, and DT. Brown emphasises how teaching through linking subject areas are productive in strengthening pupils' learning. This is supported by the outlines produced by the Plodin Report in 1967, as it claims division of the curriculum into subjects tends to interrupt children's development, trains of thought, and of interest, and hinders them from realising the common elements in problem solving. Another benefit of cross-curricular themes is that they are more advanced in addressing the changing times and uncertain future, as Alexander claims. Additionally, cross-curricular methods have proven to have motivating, inclusive, enriching, and uniting effects. Reflecting on prior experience, programming was integrated across the curriculum in Year 2 by retelling true events and stories such as the first man on the moon in literacy. In music, we was able to compose our own music, and additionally was able to replicate the moves we made in our dance performances in PE by importing photographs taken of the different moves and mirroring them within Scratch. Using Scratch to contribute to an array of subjects in children's interests supported Papler's argument of in order to access programming, it must have wide walls, meaning it provides for children's different interests and learning styles. For my future practice, I will ensure that I provide opportunities for children to explore programming across the curriculum subjects, ensuring that the contexts in which they experience coding are meaningful and make explicit connections to how they can use the skills they exercise from programming to solve problems across the curriculum and through their everyday lives.